Alrighty here. So the equations for both lines are actually given on the left. As you can see, their slopes are equal. The coefficient of x on each line is 2. So what I'm talking about here is, if you notice here, remember our point slope form from the last lesson. Both of these lines are in point slope form. And recall that our slope is always next to your x here. The number that's always written right next to x should always be your slope. So in this case, I noticed that my slope is 2 for both of the lines. And so it's interesting because it says here also, as you can see, their slopes are equal. Okay, so we said that. But then there's something important going on right here, and it says if two lines have the same slope, then they are actually parallel. And you can actually see here that these two lines look parallel. They look like they're headed in the same direction forever, and that they will never cross each other. They will never intersect. So they must be parallel. And so this is actually a theorem. And maybe if you have, still have a definition sheet, or you have a little notebook that you're writing some notes on, this is a very important theorem that lines are parallel if and only if they have equal slopes. Or I could say two lines with an equal slope are for sure parallel. But it says here if some lines are parallel, then they must have the same slope. The converse also holds. Oh, that's basically what I said. If the slopes have this, if the slopes of some lines are the same, then they must be parallel. So I can make two conclusions. I can make two different conclusions about this. That one, same slope equals parallel lines. Or I could say parallel lines equal same slope. So that's basically what this is saying here. All right, moving on. Before we move on, I want to remind you of the point slope form equation from last lesson. And so that equation looked like this here. Okay, and each item represented a different piece. And remember that I was saying, and some of you who joined the Zoom session, we were talking about that there's always some given point and the slope. And each of these items are within this point slope form here. I had given the tip that your K is always this is your X, this is your Y, and you see that Y is K. And so therefore, it's next to the Y here. Your H is your X technically, and it's next to X here. Sorry, this is getting a little crazy. So now today we're going to talk about another form, and this form here is actually a form that is most common in Algebra 1, y-intercept form. And the y-intercept form almost looks like the point slope form, and you can actually go from point slope form to y-intercept form if you moved some pieces around, and that's why they look super similar to one another. But this is that one form that's so common to us that I will never forget for my life, is that y equals mx plus b. This bad boy right here. This is called the y-intercept form. Now, the variables represent different items. So your m, again, you notice how it's right next to x. That represents your slope. And then this b, that's always your y-intercept. That describes where the line crosses the y-axis. So if you had a graph here and you had a line, this point right here is your y-intercept. That would be your b. So in Algebra 1, you learn the y-intercept form. In the image on the left, it tells you exactly what each variable represents. One of the most important things we care about in this formula is the slope m. So with all this being said and what each item represents, I would probably write this down because this is like the perfect thing. But one of the most things that is important for this lesson is knowing that this here is your slope right next to your x value. Now, with that being said, let's kind of go back to our point slope form for a second. And I'm asking you to write an equation of a line that is parallel to y equals 2x plus 3 and passing through a specific point. So remember, they give you that point here. This is your x, this is your y. That's your point here. Now, what's your m? Your slope? That's somewhere here. Because they're saying that it's going to be parallel to this line. And what did we say earlier about parallel lines? Well, if they have the same slope, then they're parallel. So, with that in mind, go ahead and tell me what your equation would be.